Well, hello everyone, and welcome to this session of the AI Nurses Network webinar series. We've got a great nursing colleague with us today, Dr. Nathan Blake, who's going to talk to us about vibe coding for nurses. Over to you, Nathan.
Thank you, Siobhán. Well, welcome to this vibe coding webinar. So deliberately created for nurses. And in fact, this whole presentation I've created using a modern AI system, an LLM, to actually make this slide deck. And I thought it's a great opportunity, since I'm talking about vibe coding and using LLMs for certain things. I thought, okay, this is a great opportunity to see what an LLM can do, a large language model can do for making slide decks. And this first page is a perfect example because it's actually okay. It's actually done a reasonable job. I didn't type any of this out. I just asked the large language model come up with a slide deck. This is the first page it came up with. And I think on a first inspection, actually it's okay. But on closer inspection, this isn't what I would have generated. It's a bit simplistic. I've kept these infographics, but they're not great, let's say. The only thing I added was the AI Nurses Network logo. And that's going to be a recurring theme of a lot of this talk, that you can use large language models for vibe coding, and they will get you quite far. But you always got to remain the human in the loop. You've always got to keep an eye on what the LLM is doing, and just make the assumption that it's not perfect. It's always going to make little mistakes. And so part of your sort of job when you're vibe coding is to keep an eye on that and make sure the LLM is doing what you think it's doing. One of the things it omitted was my name. So like Siobhán said, my name is Nathan. I was a nurse, and I've since then got to be an AI researcher. So I sort of have a foot in both worlds. And I do a lot of vibe coding myself. I learned to code myself originally in Python. And since vibe coding has taken off, I've also got my foot into vibe coding as well. So I think I'm as qualified as anyone else to talk about this. So what's on the agenda for today? We'll talk about vibe coding, of course, but beginning on what coding is, and then why nurses might want to code. We'll look at some real world considerations of what that might actually look like in clinical practice. And perhaps most important, we'll look at some of the risks of vibe coding and coding in general. And then we're going to do a live demonstration. So I'll actually pull up a large language model and we'll do some live coding so you can see how it works and how it doesn't work, perhaps. So what is coding? So coding also sometimes is called programming. There's sort of many ways you might better define it, but just at a high level, we can think of it in terms of a process of writing instructions to tell a computer what to do. And programmers, we use languages, computer languages or programming languages. I like this word languages because it gives you this impression of communicating or talking to a computer. And that's kind of what you're doing when you're coding. You're talking to a computer, trying to give it instructions to tell it, okay, we want to do this. Let's do this. Many uses, and this is just a very small subset of possible uses. So for myself, for instance, I use it a lot for data and statistical analyses. Other people are more interested in making, for instance, websites. Some people enjoy making games using coding, and that's not a trivial thing, actually. Recently, as a famous example, Demis Hassabis, he recently won a Nobel Prize in chemistry for his work in AI on something called AlphaFold. Don't need to know the details, but he started in the gaming industry. He made a great game I used to enjoy in my childhood, Theme Park. And it's a good way to get into coding, into programming, just making very simple games. There's no real stakes. It's just for you. Just have a go and see what fun you can have. And you can then go on to making more complicated things. Lots of people like to look at creating apps, and you go all the way up to creating robotics. You've got a whole range of things that you could do with coding. And famously, we often begin with tutorials with the hello world example. So this is just written in Python. So as simple a program as you could possibly have, where you just ask the computer to print hello world, and it prints hello world. So you can start there and then work your way all the way up to self-driving cars, where you have reams and reams of code, up to many millions of lines of code in order to drive a car, and everything in between. So we've got a real gamut of possibilities here. We'll be starting quite simply though. So if that's what coding is, what is vibe coding? So this is where you start to use, I've mentioned LLMs a few times. So it's where you start to use some kind of AI assisted programming in which you describe your task in just plain English or whatever language you want. And then the large language model will generate code based on what you've said. So it's just an extra interface for you to communicate with your computer so that you can specify your task in the everyday language that you would use. The large language model, the LLM, will then convert that into a programming language, which will then talk to the computer and get the computer to do whatever the task may be. So like I say, key feature, natural language. You could just use whatever language you're comfortable with. The code is typically generated very quickly, depending on the complexity of the task and exactly which LLM you're using. You can have some LLMs will spend more time thinking about certain tasks if you specify that. And it's truly a great way to very quickly go through ideas and just prototype ideas, say, oh, I've got this idea for an app or something. Is it even vaguely viable? Well, I can just throw something together quickly, just get a quick feel for, okay, is this viable? Is this not? Is this the direction I really want to go in? That sort of idea. And I think perhaps most important, not just for nurses, I think for many people, it makes programming accessible to a whole new audience. So maybe you've had ideas in the past of ideas for apps or websites or whatnot, but you've always felt, okay, that means I need to learn coding, and that can be a barrier to some people because it's requires a bit of time to learn how to code. But now with vibe coding, it reduces that barrier drastically, and you really can just have a go, and we'll see an example of that later on. But it's not without its concerns, and we'll be discussing some of the risks of that as we go along. Vibe coding, it's a pretty new term. So Andre Karpathy, is a very prominent programmer. He worked in Tesla with self-driving cars, worked in OpenAI, who made ChatGPT, which you may have used. So he first coined this term vibe coding only as far back as February 2025, so not long ago at all. And quite quickly within the year, it became one of the words of the year. And now you hear this word everywhere, not just in healthcare, but absolutely any profession, especially professions which have already do coding. Vibe coding is an absolutely huge buzzword. And more recently now, healthcare practitioners of various types, doctors and nurses, are thinking about and experimenting with vibe coding and how that might work into our existing workflows. So I've been talking about this narrative of communicating with your computer, and there's a history behind that. So when the very, very first computers were made, people were having to talk to them in binary, essentially. So just ones and zeros. So this is the language that the computer ultimately understands and executes when it's performing whatever task you've given it. Ultimately, for it to do that, it needs to understand ones and zeros, so binary. However, quite quickly, lower level languages were created. So assembly is a very famous example, which are still pretty opaque to humans. Only the most sort of specialized humans can sort of understand. But you can already see there's a little bit of syntax there which you may understand. You've got words like add and mov, there is move, ret, return. So it's starting to at least have some recognizable words. And then it's not really a binary thing, but then there's a continuum going on to higher and higher level languages. And it's an example from Python, which is quite a high level language, where you can see that we're actually starting to use actual words you can understand. And these are all doing the same task, by the way. So these are all just adding the number 3 to the number 5. That's all it is. But you can see how the syntax is becoming more and more understandable. And that finally manifests with large language models, in which you'd give your prompt, you just type what you need in English. Then what the LLM would do is it would return something, probably in Python. If you don't specify a language, my experience anyways, it normally returns things in Python, but you can specify what language if you wanted another language, and it will give you the code in Python for you to then run. Although some LLMs also give you the possibility of running the code within the environment that the LLM sets up, but getting ahead of ourselves now a little bit. So is vibe coding the future? So like I said before, it really is a buzzword that's it's everywhere in many industries. And you'll speak to different people, you'll hear very different opinions, and it'll run the whole gamut. Everything from people who are saying, yeah, absolutely, you've got to vibe code. People who don't vibe code, you're going to lose out. You're going to lose your job. You have to be able to vibe code. And that's including people who actually already code and really already know how to code to a very high level. But then you've got the other end of that spectrum where people say, no, 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 vibe coding absolutely destroy whole industries. It's a poison chalice. We can't go down this road. I think the truth is likely to be somewhere in between those two, in that actually it could be useful, but certainly there are sort of risks associated with that. So some of the potential benefits there, we've already touched on a lot of them. It's the same ideas of being able to rapidly iterate and go through your ideas, lowering the barrier to entry, especially for people who aren't programming. And it just hopefully, in the best case scenario, reduce development costs and the amount of resources you need to throw at certain problems. But I really do think that one of the true benefits are it does lower that barrier and makes coding sort of more democratic in the sense that it's now more accessible to people. Assuming you've got access to an LLM, so it's not completely democratized. You still need access to an LLM. But then other side of this, people who are sort of detractors of vibe coding, they'll mention things like the risk of de-skilling. So if you already can code and then you start vibe coding, your skill of coding can atrophy if you're not careful. And I think that's not unique to vibe coding. That's something all of us humans interacting with AI need to be aware of, that we can too easily let LLMs do our thinking for us. And so our critical thinking skills may atrophy. So that is, I think, a genuine concern that we need to take into account. Also, these detractors, they would probably advocate for vibe coding not to be a replacement for humans, but to be an extra tool, an adjunct for humans coders to use, and that humans should always remain in control. If you're coding, you're gonna be making errors. That's the nature of coding. But errors can be subtle, and so sometimes you have. So, like I said, I learned coding. I learned coding the hard way, where I just tried things, and so often I'd get errors. But the errors I liked were the errors where the system would have a big output saying, error, you've made a mistake. They're the good errors because it's obvious you've made an error. There can be more subtle errors where the code actually runs, but it's not doing what you think it's doing. And that's very common in vibe coding, actually. You do need to keep a close eye on that. It's very good at returning code that runs, that does something and it looks right, but is it actually doing what you want to do? And then we've got to be careful also of data privacy and patient confidentiality. That's a particular concern for us working in the healthcare domain, and I'll talk about that a little bit more later on. It can also make your code, and whether this is a good thing or a bad thing is debatable, but it can make your code harder to maintain in the sense that because you didn't write it, you don't actually know what went into it. If 2 or 3 years later down the line, your code actually gets implemented in some system and you need to go back to change it somehow, even if it's doing what you want it to do, but you want to go back and change it, because you don't actually know exactly what's going on, it's much harder to do that task. And the final concern, far from least, is the bias implicit in LLMs. So this bias isn't unique to large language models. This bias ultimately comes from us human beings. So there's just biases existing in the world, and these LLMs were trained by data collected from the world. And so those biases have translated across the LLMs. And there are many efforts to try to mitigate that, but you always need to bear that in mind, that these LLMs can give biased outputs in various ways. So just various things to keep in mind. So I'll let you decide whether vibe coding is the future or not, although if you listen to this webinar, I think you're probably biased towards one way or the other. So what can it do for nurses? Should nurses care? So again, don't think this is an exhaustive list. I think actually this was one of the slides that the LLM produced and I kept in. So I think I changed a few things though. So it can, like I said, mentioned before, automate repetitive tasks. So if you find yourself doing something on a computer again and again and again, you're just like, oh, this is boring. If you ever have that feeling of this is boring, it's almost certain that you can get a computer to automate that task, save you time, save your boredom. Like I mentioned before, people like to make apps and tools with it. So kinds of things you might look at sort of risk calculator. So, a fool's risk assessment, for instance, could be automated. And like I said before, you can just test ideas and just see, okay, is this working how I expect it to work? What does this look like? Oh yeah, you can see, that's interesting. It's got build custom tools in twice. So here, very interesting demonstration of how LLMs can go wrong. They are often repetitious. And actually, I'm not seeing this because it's made the exact same mistake. That's interesting. But a good case of what the kinds of things you need to keep an eye on. Large language models are very verbose. They like to talk. And we'll talk about that again later on. Maybe an underrated benefit of learning some vibe coding is that so I go to lots of symposia, lots of conferences, speak to lots of medical professionals who are interested in AI in one way or another, but they are very heavily weighted towards doctors, basically. So doctors, they do a lot of coding, a lot of vibe coding, and they're starting to get into this world already and sort of know the lingo, so to speak. And so I think that there is a real case that at least some nurses sort of need to know this lingo as well, so that we can be able to speak that same language as our sort of medical AI colleagues are as well. And while you're doing that, I think you're also empowering your professional development. Like I said, I don't think it's something AI is not something every nurse will want to or indeed need to learn, but I certainly think that some nurses will need to learn AI. In the same way, if you work on a ward, you may have one nurse dedicated to just have an interest in sort of diabetes. They'll be like the diabetes specialist of the ward, and you have another one for wound care, so to speak. So I think in the future we'll have a nurse dedicated just to having some AI literacy. And I think vibe coding is an excellent way to get into that world. I think perhaps most importantly for nurses. So this is my experience of nursing, but it's very often the case that nurses we're the first people to come across and identify problems, and then we may sort of flag that problem up and get the powers that be to notice that problem, and maybe many months later, some solution will be found, but it would be normally just be imposed upon us. So, we'd be the first people to flag it and the last people to find out about the solution. I think vibe coding at least gives one potential tool to actually empower nurses. So it's not just a case of we point out problems. We can point out problems and then come up with a potential solution. Not saying the whole solution. I'm just saying you can go to the powers that be and say, okay, I found this problem. Here's what a solution might look like. Here's a little program I made that might solve this problem. And it just gives them an idea of what you think a solution might look like. And that just might help empower nurses to guide those. And like I was saying before, AI, like I say, medical practitioners are becoming more AI literate. AI is coming to healthcare. Exactly when that's going to take off is debatable, but it is coming. And I think it's either going to happen to nurses or it's going to happen with nurses. And if it's going to happen with nurses, like I said before, at least some nurses are going to have to become AI literate. Here are some real world examples. This slide is entirely AI generated, but I did check it all. And 3 of these real world examples are actually real world examples. One, the LLM hallucinated, completely made up. I'll let you have a little think about which one you think is completely made up. None of them are published in academic literature, actually. These were all the ones that are real were published by journalists, essentially. But it's just a demonstration of the kinds of things that you might do, whether you're like it's a general medical practitioner or a surgeon or a biomedical researcher of some kind. So the one that was made up, unfortunately, was the nurses. So I couldn't find actually any real life use cases of nurses using vibe coding to actually come up with not so much to come up with a viable tool, that's not the point, but to come up with a prototype tool. So all these other ones, like I said, they've not been published academically. I don't think they're actually really used, but it's just a prototype and come up with examples of the kinds of things that surgeons, for instance, might want. And then they may well go on to being developed into fully fledged tools. But there is some research into whether vibe coding is useful for nursing. Well, this is the only paper I could find, the only empirical work I could find by a Korean team. So they just had 5 clinical nurses vibe coding for a certain amount of time. And long story short, they basically found that this vibe coding session was useful to the nurses in terms of giving them some agency and a sense of being, there's another buzzword, co-creators involved in the sort of development of identifying problems, but identifying potential solutions as well. So it's a recurring theme. I do think it's important. I think this is the most important thing that vibe coding can potentially give the nursing profession. So this is another completely AI generated slide. And in this case, it's fairly repetitious. Can you notice how a lot of these AI slides are quite repetitious? And in this case, it's just giving some example use cases and some potential tools that you could use. I'm not going to go into the details of those. I think the most important thing I want to point out is that I would not recommend letting the LLM dictate your ideas. Rather, you come up with the ideas and then you approach the LLM and saying, okay, I've got this idea. How help me implement this idea in the real world? Because at the end of the day, large language models, coding in general, it is very powerful. Large language models can give the illusion of being extremely intelligent, and it'd be very easy to defer to the LLM and think, oh, it's using all this fancy language I don't understand. It really knows what it's talking about. They make, like I say, the reason I've kept in a lot of these mistakes from these LLM generated slides is I want you to show you, actually, no, LLMs are full of mistakes. They don't think, well, that's debatable. I don't think they think. They certainly don't think like humans. And one thing I think at least at the moment, and potentially for the foreseeable future, is the creativity of generating ideas still resides with humans. So I strongly recommend that you don't use it for your ideas. You use it to realize your ideas. And that's not to say that you can't use LLMs to bounce ideas off. I often do that with LLMs and just, okay, I've got some ideas. And instead of Googling around, as I might have done a few years ago, I now go on LLM and just chat with it and go, okay, I've got these ideas. What do you think of this? That's one thing, but that's different to just letting the LLM have complete control and dictate to you, okay, let's do this. So I'd strongly recommend you retain ownership of your ideas and approach the LLM and say, okay, we're going to implement this idea. So I've already touched on quite a lot of risks and challenges. And we've already seen some inconsistent quality in the slides that it's generated. And it's always got this famous problem of hallucinating. So large language models, they are a type of generative AI. So the key word there is generative. In a sense, they are literally making stuff up. That's what they're designed to do. They're made to make stuff up. In the best case scenario, they make stuff up which is aligned with what you want, but that's not necessarily the case. And when that doesn't happen, when it does make stuff up that you don't, that's either doesn't correspond to the real world or is just not what you want, these are often referred to as hallucinated outputs. So that's something you do need to keep a close eye on. They do hallucinate. We've already spoken about the sort of hidden bugs, which is sometimes referred to as technical debt. That, like I say, even though the code is running and it's doing something, and it might sometimes even look like it's doing what you want it to do, there can be subtle little bugs. And especially if you're making the larger and larger the code base you're producing, the more likely you get these bugs interacting in strange and interesting ways. It is odd when you start to code thoroughly, code interacts in strange ways. It's almost like it's like a living system where just they break down in odd ways, interact in odd ways. Interesting, but potentially dangerous. So do keep an eye on it. It's also possible that you can get security vulnerabilities. So don't start doing this on NHS computers. And some sort of real world use cases of that where maybe I shouldn't mention them, but some sort of famous LLMs sort of got themselves into trouble because they gave the LLM sort of full control of the computer and said, do what you want. And this LLM will just start erasing things and causing all kinds of problems. So something to keep an eye on. So that has problems for scaling these LLMs in the code produced by LLMs when you're having big projects. So certainly for us, certainly to get started, just keep the project small, should be fine. But you often get non-reproducible results. So it's just very interesting. Just as an experiment, something I'd recommend you try doing is just give an LLM the exact same prompt. Just ask it to do the exact same thing, and you see how many different types of answers it will give. So very often give a different answer, even though it's ostensibly the same task. It's the same task from your perspective, but it might interpret it in a different way. And sometimes that's just a case of the syntax looks different, i.e. the code it gives looks different, but it's doing the same thing. But other times it's actually the code is doing different things. And we'll go into more details, but there's also regulatory and compliance issues around. And, that sort of point, you certainly want to start to get specialist input. So this is another one of the LLM's generated slides. There are many regulatory and compliance sort of frameworks out there. I would recommend not worrying too much about the technical details of these, unless you're really going in and trying to get some code in the real world. But while you're just playing around on your own laptop, so to speak, you should be fine. But I think if you bear in mind one principle, and it's a principle that should be instinctive for a nurse, just remember, you are a nurse and you hold a privileged position in terms of access to patient data. And that's something I really notice now. I've left nursing, and all the data I used to have access to when I was a nurse. But your first duty is to your patient. Just think, you're a guardian of the patient in many ways, and that includes your patient's data. So you are a guardian of your patient's data. So if you just have that mindset, I don't think you will fall foul of any of the regulation. So that's why I say don't worry about the technical details of the regulation. If you just have that principle of you are a guardian, you're protecting your patient, and that includes your patient's data, I don't think you can go far wrong. So this is what a workflow might look like. This again was an LLM generated slide, and there's one of these I sincerely disagree with. So we'll get to that. So first is defining your problem. Like I say, I'd recommend you're the human, you stay in the driving seat, you define the problem. You have the clinical expertise, even though these large language models have access to the entire world's knowledge. it doesn't know as much about nursing as you do. You can then sort of generate code. There's different ways of doing that. Like I said, I mentioned Python a few times. That's just because of what I use. No reason why it has to be Python, can be anything. And then once you get some running code, like I say, it's make the assumption that it's got something wrong in it. Even if it's running and it's on the first pass, it looks like, okay, that looks right. Actually, just assume that it's doing something wrong and run many tests and run the code in different ways to verify it's actually doing what you think it is doing and what it should be doing. And this last one, so deploy and share. So it's talking about integrating solutions into your unit with IT support, document of colleagues. So I disagree with this one. So I'd actually put a big cross and say, no. I don't think we should be, if you're just starting off vibe coding, to begin with, certainly we shouldn't be thinking about deploying things in the real world. Like I say, it's good for prototyping, and it's good just to increase your AI literacy. But so let's say you do use vibe coding, you do make some prototype of an app, let's say. Certainly share it. Certainly share it with other people on the ward, other stakeholders who might be interested in it. You know, if it's got something to do with drug errors, for instance, pharmacists might be interested in. And you know, like I say, I think it's really good for making these prototypes. And then if you're thinking of actually deploying it into real world, that's when you have to bring in a whole nother team and get in some real human expertise. Like I say, LLMs, they are great. They're great for many things, but when you're interacting with the real world, I wouldn't trust an LLM. So safety and ethics. So this is another one of these LLM created slides. I've talked about all these before. So just notice how repetitious these LLMs are. They talk so much. LLMs love to talk. Um, so they generate a lot of unnecessary, superfluous information. So again, this is something I've left in deliberately, just so you can start to become aware of it and just notice the sort of patterns that LLMs have. In the same way, you know how it is when you're working with your colleagues and you'd have certain nurses who just have certain habits, certain tendencies. It's not a bad thing, it's not a good thing. It's just they have that sort of habit. And some of your colleagues probably talk a lot. Maybe you might think they talk too much. Most LLMs I've interacted with talk too much. They talk a lot. So like I say, it's not necessarily a bad thing, it's just something for you to keep an eye on. And if you're generating a slide deck automatically, keep an eye on it because it will repeat things. And it will repeat things in subtle ways. So this is a whole new slide, safety and ethics. Sounds vibe on the first inspection. That's great. When I actually read the points, it's like we've said all these things before. So it's repeating itself but in a different way. So how do you get started? Hopefully I've convinced you by now that even though there are risks, it is an absolutely useful skill and something. It's such a low-hanging fruit. There's really very little stopping you. All you need is access to a large language model, and the vast majority of them you have paid for plans, but the vast majority of them have a free instantiation as well, so you can just get started. And obviously the ones that you pay for are better in some sense, but certainly getting started, the free ones are more than good enough. They're pretty excellent actually. So say in terms of getting started, I would recommend just start, just try. Just start chatting to an LLM saying, okay, we're going to be trying this. I've got this idea. What about if we do this? And it's very chatty. I mean, if you haven't already spoken with an LLM, they are very chatty. You can just bounce ideas off them. They will respond to your tone. So if you want a more somber and serious tone, you know, the LLM will sort of plug into that and be more serious. If you want to be a bit more jokey, the LLM will respond to that. And just practice prompt engineering. So prompt engineering is just a very fancy term for knowing what to type into your prompt to get the response that you want. So like I say, LLMs, the way I think about LLMs is you know those shopping trolleys when you go shopping, Tesco's, whatever, and have a trolley that just veers off to the left slightly all the time. It's always veering off to the left. And then you try to correct it and it lurches dangerously to the right. LLMs are a bit like that, in that they get you broadly into the right space, like I've hopefully demonstrated with this slide deck. They're pretty good, they're okay, but they're kind of veering off a little bit. Now, I corrected them myself. I just went in and corrected them myself. If I tried to use the LLM to correct itself, it probably would have just lurched off to the right, and I would have spent hours just trying to get it just so. So the way I'd recommend using them is use an LLM to get you into the ballpark, and then you can just sort of finesse little things here and there. And just start playing with it, build little small projects. It doesn't even in the first instance have to be related to healthcare at all. I mean, I had a friend of mine who started cataloging his food he had in his cupboards and made an app to tell him when he needs to order certain things and generate a shopping list at the end of the week. It could be as simple as that. Or maybe you want to do that for your storeroom. I don't know. Many little possibilities, but they're the perfect little kind of small projects just to get dip your toe in, just to get used to it. There are various informatics courses and training programs, such as this webinar. The only thing I would say about those is, and this is maybe a personal thing, I like the programs in which you see things go wrong. And you may see an example of that as we do a live demonstration of using a large language model. But the reason I say that is because if you're going to be coding, including vibe coding, don't expect things to work first time. Things will probably look kind of right, but there will be little problems. And just so get used to that idea. And so I personally distrust any training program where everything just runs perfectly. You say, oh, you write this code and this will happen. So it never works quite like that. And perhaps once you've done a little bit of vibe coding and you get sort of comfortable with that, why not learn? I've written Python here just because I'm so used to it, but learn something about computing languages themselves. And the LLM can do that with you. So if you've done some vibe code and you've had your idea, it's generated some code, you can look at the code and just go through it and actually ask the LLM, oh, actually, what are you doing here? What does this line of code mean? What does this syntax here mean? What does this loop mean? And LLMs are very good at explaining that. Again, with the caveat that they can make things up. But generally speaking, they're pretty good. They're pretty good for that sort of thing. So just a couple of very brief resources. Since you're here, I assume you already know about the AI Nurses network. But there is a YouTube channel associated with that where people talk about just AI in a more sort of general sense. I know we're talking about vibe coding here, but I think it's just the whole AI ecosystem is of interest. So that's a UK specific one. There aren't too many so AI nurses resources. So this is the only other one I could find, which is the American College of Nursing also have some AI resources as well, which may also be of interest. And with that, let's do some live coding. Siobhán, do you want to help out with the live coding in the sense that it might just be a good sort of to have a back and forth? I might say, oh, what shall we ask it? Or what idea? Just to give an idea of because if this was a live demo, I'd be asking the audience, oh, what shall we do here? Would you mind?
Yeah, go for it, sure. What could go wrong?
Yeah, exactly. What could go wrong? Let me get rid of PowerPoint. Oh, let me just reduce that.
Just while you're getting that set up, I know there are some coding communities in the UK, and I'm sure in other countries as well that are running free sessions on vibe coding, and yeah, so I'll share those on the network as well soon.
Oh yeah, that'd be brilliant.
Yeah, there's some here in London. I'm sure they're in other parts of the world.
If I share, I stopped sharing, haven't I?
Yes, yeah.
Okay, let me share screen again.
Oh, great. ChatGPT.
Let me hide this taskbar. Okay, what's on your mind today? So I'm using one particular large language model. Not that I advocate for any one over the other. It's just this is the one that I've got used to. And it is interesting, actually, like I was mentioning before with large language models being something like a colleague and having certain tendencies. It is interesting when I try to code in a different LLM, there's just a slightly different feel to it, a slightly different vibe to it, so to speak. So I've just got used to the personality, so to speak, of this particular LLM. So I'll be using this for the demonstration. So in case you've never spoken with an LLM, this is a kind of quite typical layout where I have this box here is where I put the prompts. So when I was referring to prompts, this is the window I was talking about. So this is where you type what's on your mind today. So I've already put in a little description of the kind of thing that we're doing. So the reason I've mentioned here, for instance, like we're a team of nurses demonstrating the potential of vibe coding. It's not a bad habit to get into of thinking from the perspective of the LLM. The LLM really knows nothing. It knows nothing of what you're doing. So giving it a little bit of context often helps just keep it within sort of a reasonable ballpark of what you want. So I wanted to produce a simple task because if I give it free rein, it might try to, I don't know, create a surgical robot or something. Who knows? And then maybe we should find out. I don't know. And another habit, and this is just me, a habit I've got into is I like it to generate several suggestions. If I'm asking it for certain ideas, it will just if it just gives you one idea, yeah, that's okay. But I often find if it gives you several ideas, it gives you as a human some agency because then you can sort through those ideas. And I think, okay, that idea is okay, but needs refinement, or none of these ideas are any good. Try again. So let's find out what suggestions the LLM has for us. They're typically pretty quick, but so this particular instantiation automatically decides how long it should think. So it took a few seconds. Sometimes it can be much quicker. So yeah, it wants to solve a recognizable nursing problem. Simple enough to build in 5 to 15 minutes. Okay, that sounds good. How we do it for time, Siobhán? Does that sound all right?
Yeah, sounds good. I think we can do it.
And yeah, we want an immediate visual result. And with little to no healthcare integration. That's excellent because I'm on my laptop. I don't want anything. Also, it's recommended either an early warning score calculator, shift handover generator, IV fluid rate calculator, pressure ulcer risk calculator. Oh, how many has it gone? Okay, I won't read all of
Loads.
these.
10.
10 ideas, not too bad. But can you notice already how verbose that is? It's it does like to talk a lot. Siobhán, did any of those
Yeah, to be honest, the
grab
very
you?
first one, because that's what I was thinking myself, that's what
Yeah.
if
That's
nurses are
funny
doing
actually.
obs every day.
That's exactly the one I was thinking of doing actually. That's quite interesting. Okay.
Yeah, great. Sounds
So
good.
okay, let's do that. Let's copy and paste this. Let's produce an early warning score calculator. Um, let's see what it does. I'm not going to specify any more instructions than that. I just want to see how it behaves if you give it minimal instructions. Okay. So it's thinking, oh, so this is something this particular LLM will do sometimes, and it's something to keep an eye on. So I don't know if you noticed there, it starts searching on websites. So it's actually searching the web and to generate its idea, and you can see it generating HTML code. Interesting. Well, I didn't specify a language, so we'll see. That's interesting. I might need to go back and specify Python because I'm going to be implementing this code in Python. Oh, interesting. So how long did that take? So it took 9 seconds. So you can see how quickly you can iterate through ideas. And it's produced that was actually a lot more code than I was expecting. I did try this off camera a couple of times just to make sure it's not totally wonky. And it didn't generate anything this comprehensive. I I preferred it to work in Python. It normally does produce Python, but in this particular LLM, it does have a way of running code without actually going into an environment. So the LLM
Great.
itself, yeah, it'll open that environment and it'll run HTML. I've never tried it with HTML, so we'll just run it and we'll just see what happens. But that's, like I said, this is the great thing with vibe coding. You can just see what happens. It's oh, so it's made this early warning score calculator. Look at this.
Great.
This is looking all right. This is looking all right. So obviously you've got here some boxes where you can either use the arrows to go up or down. Can we type in live as well? Okay, let's say 15.
Good.
Yeah, that's great.
Great.
Okay, SATs, great. Supplemental oxygens, fairly thorough. And you've even got, oh, new confusion. Okay, so it's just giving you a binary, has it? Yes, so either new confusion or alert. So not quite GCS, but still interesting, interesting. Demonstration only. This is not a validated clinical system. It should not be used for patient care. Fair enough. Good that it gives those warnings though. And I've noticed that recently LLMs are very, very cautious. Anything healthcare related, you will often see this kind of output. So you gotta imagine, okay, it's fine, we're healthcare professionals using this, so we should sort of know to keep an eye and make sure it's not going wrong. But you can imagine a patient, anyone could have done this. And so having those little messages are quite useful. So let's calculate the score. Okay, great. Total score 0, low clinical risk. Let's go in again. Let's give this patient what should we give this patient, Siobhán?
Yeah, I was wondering how robust the data entry was. So for the supplemental oxygen, can you go above 100% or does it count? Yeah, it
So
probably
it's
doesn't.
either yes or no for supplemental oxygen. Let's see,
Or
shall we see
sorry, oxygen
saturations of
sat, yeah.
120 and see what happens? Let's see, how robust is it to that? Has it calculated the score again? I'm not sure. Let me just
Yeah.
see what happens if I put 20, because hopefully that should flag.
Yeah, that's
How
brilliant.
interesting. Okay,
It's a
so
low clinical risk. My
so
goodness.
when your oxygen's at 20%, but the interesting thing is, notice here, the risk score is 3. Now, I don't know what that means because it's given no context, but it's also flagged it as low clinical risk. So this is exactly this kind of scenario where we'd like to go into the code, and you might. So when you're vibe coding, it depends on how much detail you want to go into. I myself, because I'm used to coding, I'd be quite happy and comfortable going in here and trying to work out what's going on there. And I already have some ideas of why it's got that wrong. It's got the calculator bit correct, so it's creating an extra score. But for some reason, that score is not corresponding to actually the output of this has gone wrong. So what shall we do? Well, there's a couple of options we have here. Let me run it again. We could just tell it that it's got that wrong. We say, I often find it useful to actually give some reward signal to the LLM when when it's got something right. So I say, overall, um, this looks good, but there's a big but the scoring doesn't quite work. This is while I'm typing something else to note, that these large language models are quite good with typos. So if you do put in typos, large language models can normally work out what you actually meant very well, actually. It doesn't quite work. When the SATs, let's see if it actually knows what I mean when I use SATs. Maybe I'll spell SATs right. When the SATs are 20%, it gave a risk score of 3, but clinical risk was described as what? Was it described as safe, was it?
Or low risk, I think, yeah.
As low risk. Let's see what it says. So it's going to predict it. I think it's going to say, you're right to point that out. I will endeavor to solve it. Let's see.
Yeah, because if it pulled the calculations off the web and maybe hopefully some good sources, then that Shouldn't be happening in theory anyway.
Shouldn't be happening in theory, absolutely.
Yeah.
Absolutely. I'm quite surprised by that mistake, actually. Normally, it's for this kind of a calculator, quite simple one. I would have thought it'd done quite well. But I love this. Like I say, it's a good example of things going wrong because the calculator worked. So on the first pass, it worked. And it's only because, Siobhán, you sort of knew with using your clinical knowledge, like, oh, what happens if we do this? What happens if we do that? So you just stress test it. So it's tried again. Exactly what it's tried. Oh, so here's a funny thing. So what it's done is it's identified what it thinks is the problem, and it's given an example of the code amendment that it needs to make. But what it's done is, whereas before it gave the entire code and said, run this, it will work. This is just a snippet of code. So what I'm going to need to do is ask, okay, great, but I'm going to have to need it to give the entire code so we can run it.
Yeah.
So this is something that happens. So I said, okay, that's great. Please give the entire code again with the amendments. And just to prove that typos don't matter too much, I'll let that spelling mistake roll. And here it is again, using that code again. It's quite fun. I quite, maybe it's a personal thing, but I quite enjoy just watching it produce code as you go.
It's just so fast. Imagine if you had to write it all yourself.
Yeah. Oh, absolutely. Absolutely. I mean, that in itself, that's probably, if you know exactly what you're doing and you know this language well, that's probably still something like 20 minutes work.
Yeah.
That's if you know what you're doing. Okay, so let's see if this works. Let's preview this code. Okay, so again, it looks first inspection, it looks like it's working. Shall we try the same mistake again, see if it... I've never seen an oxygen saturation so low. I mean,
I
that's
hope
just...
not.
Let's see what it says. Medium clinical risk.
Okay.
Urgent clinical review recommended. Okay, so it's probably understating that, but it's, at least now we're in the sort of right ballpark. Medium risk, medium clinical risk. Well, this might be related to the actual clinical tool that it's using, because you remember before it went online, and there are many early warning systems out there. I don't know which one it actually used, so we'll come back to that shortly. But maybe it's not a problem with the code it generated. It might actually be a problem with the early warning score. Maybe if only one set of observations goes off, it sort of caps. Because that's bizarre. This is not clinically realistic, right? If you've got oxygen saturations of 20, your other observations are probably almost certainly going to be off as well.
Yeah.
I mean, alert when your saturations are 20. It seems unlikely to me. So let's actually ask it. Let's ask, what early warning score system did you use for this? If I were doing this by myself, I'd probably ask for a bit more information, but I'm just going to leave it like this for the time being, just so we can get an idea of what it does. Normally what I say is be brief, because as you'll see in a moment, it's going to give a lot. Both based mostly on news too, but the implementation is not a faithful news to calculator. Interesting. So I don't know how to interpret that actually. So it's used some variation of an existing tool. That's good. That's interesting to know. Like why is it taken a known tool but not faithfully represented it? So it knows it's done that.
It kind of
Why is it done that?
It says something about several simplifications below. Yeah, it might give us more detail.
Yeah, let's have a look. So okay, these are the observations that it has. That's great. The saturation scale 1. So only implements scale 1. So I'm assuming that means it's just a binary. Either gives a score of what, 0, 1. Let's have a look. Simplified response rate. I implemented low. So if it's okay, so now it's talking about the output. So if it's 0 to 4 low, 5 to 6, or any single. So here we see now, this is
Yeah.
where we see what's happened. So because there was just a single observation, the SATs were low, it's capped it to 3, so it's given it a medium. But interesting that it still said immediate medical attention. So let's go back and let's give it some higher scores. Let's perturb some of the other observations. Okay, if they've got SATs of 20, they're not going to be hot. They're probably going to be very cold. Let's give it a 34. Let's pulse go down to, I don't know, 40. These are not very realistic. So make this a bit more realistic.
Me too, yeah.
Still low, but you know. Okay, that's vaguely realistic, I guess. Okay, nice. So that's what you'd hope.
Mm.
High clinical risk. Okay, so it's behaving as you would hope it behaves. So there's a couple of things to note here. We'll end the demonstration shortly, but there's a couple of things to note. So first thing to note is how easily it generated this little tool very quickly, and on a first pass, it's exactly what you asked for. It wasn't until we started going into the details and started playing around with it and seeing how robust it is. So, for instance, if you start putting nonsensical numbers in,
Mm.
it doesn't catch that, and so that might be something you want to implement on top. So, in a future iteration, if you prompt again, we might want it to catch those sorts of failure modes. And so you saw this sort of back and forth that happens. You get your answer, you stress test it, and the more clinical knowledge you can bring to your stress testing, the better. So like I say, a patient doing this wouldn't necessarily know what to put in there to properly and thoroughly sort of assess this going on. But bring your clinical knowledge to it. Try to break it. Basically, that's what we try to do, Siobhán and I. We just try to break it. Try to break it more thoroughly than we've done even here. And every time you try to break it and you found it's broken, then you can just prompt it and ask it to make the fix. And sometimes the fix is something to do with the coding, sometimes. But sometimes there's something more fundamental going on. And the fact that it's using, I'm not too familiar, I must admit, with News 2. It's been a while since I've been on the wards. Um, so even though it found an actual early warning system, for some reason it didn't faithfully represent that. So we might, for instance, want to go back in and insist that it uses a specific early warning system, probably one that's actually been clinically validated, for instance. And yeah, I would encourage you, maybe you want to repeat the exact same task. Maybe you want to begin with the exact same prompt. If you go, excuse me, if you go back all the way to the top, begin with the exact same prompt. If you try this in your own LLM, you might get slightly different answers, slightly different recommendations. But just dive in, just have a go. These kinds of things, you can't really do any damage because we're not using any, not even touching any real patient information whatsoever. And we're not thinking of implementing this in the real world, but what we are thinking of is okay, we're all quite familiar with early warning systems, but let's say you genuinely come up with a new idea, which your colleagues might, if you try to just describe it to them verbally, they might be scratching their heads, or they know roughly what you're talking about, but I don't really. If you can actually come up with something like this and actually say, well, then I'm thinking it's this kind of thing. It might look like this. You might interact with it in this kind of way. It just concretize your ideas so much more and give some weight behind them and maybe hopefully just spur some interest in your idea and hopefully give you a little prototype which you can demonstrate in the same way we just demonstrated this to explore that.
Nathan,
So
presumably you could create a simulated data set and upload it to work with whatever tool you're creating to kind of prototype a
have
bit
we
more.
have we got time to explore that?
Not today, but something might come back to another follow-up
Yeah,
session.
absolutely. So that
Yeah.
that I was thinking actually doing that for this live go through of making up simulated data. So you've got two options there. You can either just generate completely simulated data. That's the safest one to do. But there are also a lot of free online open source and completely anonymized data sets. They're not very good for real clinical applications, but they're very good for this type of thing of prototyping. So that's another option. And you saw that the LLM, this particular LLM, had access to the internet, so it could find that data itself and just download that data as well. So absolutely, that's an absolutely viable way to go for sure.
Brilliant. Thanks so much. Well, that was a really good session, and I can't wait to play around with LLM myself because I've got a few ideas I want to test over the summer.
Great. Absolutely. Well, thanks for inviting me.
You're great. Thanks so much, Nathan. Yeah, and hopefully we might catch up with you in a few months when agentic AI started to take off in nursing and healthcare, because that's the next
Yeah,
step, I
that's the next
suppose,
big thing. That's the next big
when
thing.
you've gotten to grips with vibe coding.
Absolutely.
Great.
Absolutely.
Brilliant.
Stop
Thanks.
swearing here.